How about potential? What on earth is potential? Well, potential is defined as the work done. So electric potential is the work done per unit charge from bringing a positive charge from infinity to a location R. Okay, so in an equation, that means you want to find the work done, the amount of work bringing something from infinity to a location, but it's work done per unit charge, so you divide by Q. So what is the work done? Remember, work done is force times distance. So let's say you bring it from distance L from here to here, but you want to go from infinity to R, so infinity to a location. That's work done per unit charge, right? So you also see that F, the force per unit charge is the electric field. This is a definition, well, this is a formula, a very useful formula for the finding the absolute potential. This is the definition, but the other one is a formula, which is a very useful formula. So V is the integral of E. So you can flip that around and say that E is the derivative of V. There's actually a negative sign over here. I don't have time to just explain that, but just remember there's a negative sign over here. So what is this little inverse triangle? It's called a nabla. This is the name for the sign. What that means is it's just saying ddx and ddy. One in the x component, one in the y component, like that. Okay? So this is the nabla vector, which is ddx, ddy. If you have a z component, ddz. If you have only two dimension, it's just the first two. So that's called the del operator as well. Okay. How do you use it? Let's say I have an electric potential that is like this. Let's say it's 5x plus 3xy, like this. All right, so what is the electric field if I'm given this? Well, the electric field is this, right? So that is the dx, the dy of V. So V is 5x plus 3xy, right? So first you can multiply this inside here. So it's ddx of 5x plus 3xy, ddy of 5x plus 3xy, like this. Okay. So do it one at a time. So the derivative of 5x with respect to x is 5. Derivative of 3xy with respect to x is 3y, because you're just differentiating with respect to x. How about here? Differentiate with respect to y on 5x. There's no y over here, so everything is a constant. Differentiating a constant is 0. And then differentiating this with respect to y is just 3x. Treat everything else as a constant and just differentiate the variable that's given. And that's your answer. You can write it like that. You can write it in xy components like this. I and j, or x hat and y hat. Either way will work. All right.